My name is Shrutika Sadala and I am a member of Team 40. For our project, we have decided to produce an automatic whiteboard eraser which provides an affordable and low-maintenance solution to quickly erase marker residue. The goal of our project is to create a time-efficient and environmentally friendly solution that is also profitable and sustainable. The eraser is designed for our primary market, which are college students who use whiteboards either for academic or personal use, offering a more streamlined solution to effortlessly erase marker residue and to save time. Some assumptions that were made to restrict the concept generation process was that the solution must be less than $80, must be controlled by a microcontroller microprocessor, is a derivative of an existing product platform, and that the product must be constructed in the designated spaces. We had 7 potential customers based on our customer profile who provided our team with concept feedback, which was then constructed into a list of customer needs. This list was then analyzed and considered based on the product design and was ranked in an order that prioritized customer needs and wants, as well as what would help us achieve product success in the market. Some of the mentioned customer needs that had to be met were that the product must be lightweight, compact, ergonomic, effective in one swipe or run of the system, and must remain comfortable even with the system attached. The highest priority customer needs that were identified was that the automatic whiteboard eraser must be lightweight, quick, and strong enough to be effective in one swipe across the whiteboard. For the whiteboard eraser, we decomposed a simple, complex problem into a set of simpler subfunctions until they couldn't be decomposed any further. The decomposition was based on functions, user actions, and customer needs. Our team started off with viewing our product idea as a large black box and then decomposed it into several subfunctions using solution neutral phrases. For our decomposition, we started with the idea that it must receive energy and that it must have an on and off signal. For receiving energy, the device must be able to store energy in an external power source, which should then convert that stored energy to power an electric device. At the same time, the on and off signal should receive user input, which would then turn on the device, powering the external electric device, all leading to the eraser wiping across the whiteboard surface. The end result is that the surface is cleaned and the whiteboard is ready for its next use. During class, our team performed the 4-2-1 method, which involved the 4 members of our team creating 2 sketches each, which was then passed around at least once to let other members provide feedback and modify certain components of our sketch. Our team passed it around twice to have enough feedback. This method gave us a chance to develop potential concepts, discuss our ideas, evaluate the different solutions, and have a record of our ideas and thoughts. Some of the ideas displayed on the figure on the screen include Fallon's and Michaela's initial sketches, as well as the team's feedback and words and additional drawings. Both Fallon and Michaela had similar ideas using a gear track system to move an eraser across the whiteboard. Michaela had her eraser moving left and right, as shown in the bottom image, and Fallon had hers moving both left and right and up and down, as shown in the top image. Some of the feedback that we suggested was that wiper fluid could be installed onto the whiteboard to spray before use, or that the whiteboard eraser in the bottom image could be extended to encompass the entire height or length of the whiteboard so that it could be more effective in one swipe. To be more detailed and orderly, another form of concept generation that we used was a concept combination table. In this table, we determined 5 key subfunctions based on our initial ideas and relevant solution fragments for each subsolution. Our subfunctions were on how to receive energy, how to store energy, how to receive user input, move the eraser, and the material we wanted to wipe the whiteboard with. One solution fragment from each sub-solution category was chosen by each team member as shown and was turned into 4 potential final solutions. For example, my solution combination was a system that receives energy and stores energy in a solar panel, receives user input from a sensor, and moves the eraser made from microfiber cloth using a belt and pulley system. Fallon's solution combination was a system that receives energy from a battery, stores energy in a capacitor, receives user input, and runs an eraser that's made with bamboo fiber, which is environmentally friendly, on a gear track. Nathan's solution combination was a system that receives energy from an outlet, stores energy in a solar panel, receives user input from a phone, and moves an eraser made from felt on a roller system. Lastly, Michaela's solution combination was a system that receives and stores energy from a battery, receives user input from a button, and moves an eraser that's also made from microfiber cloth on a windshield wiper type system. As a result, our gallery method poster was created. In our gallery method, we took the previously mentioned concept combination table and the designs that each member selected and turned into detailed hand-drawn sketches as shown here. As you can see, I designed a double belt and pulley system that's powered by DC motors and a solar panel that receives user input from a touch sensor on the side to move the microfiber cloth across the whiteboard. This method gave us a chance to illustrate and imagine the design of our concept combinations, and we chose to receive feedback from other teams as well. In our feedback that we received in terms of our design and illustrations, it was all very positive, and our improvements mainly focused on the gallery poster structure itself in terms of design and format. With these unique ideas, our team took to the concept screening method and concept scoring matrix to determine our final solution. The objective of our concept screening method was to quickly narrow down the number of solutions such that the best solution remains using criteria based on customer needs and one reference solution. Similarly, the concept scoring matrix took the semi-finalist solutions from the concept screening and ranked the remaining solution using criteria that was weighted based on importance. From this matrix came about the highest scoring solution, which was our belt and pulley system. The remaining lineup was the gear and track system, the tank eraser, and the wiper system. Our reference solution was a standard whiteboard that most students with whiteboards already own. And our selection criteria was based on whether this system was lightweight, whether it could remove residue effectively, whether it would obstruct the board, whether it could be completed quickly, whether it had the ability to store power properly, whether it had a long lifespan, and whether it was portable. The highest weight or most important customer needs that were identified was whether the system effectively removed marker residue, is lightweight, and whether it quickly finishes its task. I would like to mention that in terms of our reference solution, which is the standard whiteboard with no components at all the systems we chose would have additional components which would add weight and therefore be heavier than our reference solution, hence all the negative signs for all of our lightweight systems. And this is why it would be negative, but it wouldn't be too much heavier than our reference solution. As a result, Team 40's final solution and design for the automatic whiteboard eraser has been selected. It is a double belt and pulley system powered by an Arduino Uno, DC motors, and a battery that's preferably 9-volt. The system will receive user input using a push button, and the eraser will be made from microfiber cloth. As you can see in the CAD views on the slide, the eraser will be mounted on the two pulleys, which will be able to be removed during use. The system itself does not obstruct the whiteboard space and allows the whiteboard to be used without any discomfort. To receive user input, a simple push of a button will activate the system, and the Arduino will be programmed to rotate the two DC motors, which are then connected to one pulley on the bottom and top. Thank you so much for your time.